Welcome to today's lessons on chemical formula. So by the end of the day, you will learn how to write ionic formula. Before we begin, let us think, why is there a need for us to even use chemical formula in the first place? Why can't we just use their name? So the rationale for that is very straightforward. Chemists all around the world uses their own terms for the name of the compound. However, we need a standardized language for us to understand one another. So here's some example of what copper 2 sulfate is in the various languages. Very different, right? So how do we determine the charge of metal cations is, first, we need to know when is something a metal and when is something a non-metal. So recall that you can draw this ladder from this corner down, and you can separate it into the metals and the non-metals. First, we see that group 1 would always have one valence electron, and hence they will lose one valence electron to form a positive charge. For group 2, they have two valence electron, hence they will lose two valence electron to have a full valence shell. Next, we move to group 3, who has 3 valence electron and will lose 3 valence electron to attain stable noble gas configuration. In the middle of it all are what is called transition metals. Transition metals have variable oxidation states, and that's why we need to look at their name. What variable oxidation states mean is something that you will learn in Sec 3 and Sec 4. However, at the moment, you can just think of it as having different charges. For instance, copper, let me just point out copper over here, would form a charge of 2 plus or 1 plus. To tell you which charge it is for this particular compound, we will write down bracket 2 to indicate the charge is 2 positive charge. Now for anions, again, that lays on the right side of the ladder, we need to look at the different group as well. So for group 5, they have 5 valence electron. For it to attain stable noble gas configuration, they need to gain 3 valence electron to get the octet structure or the stable noble gas configuration. Hence, gaining 3 valence electron, 3 negatively charged electrons, it will make them minus 3 charge. Following which, we see group 6, who has 6 valence electron and must gain 2 valence electron to attain stable noble gas configuration. Then group 7 would correspondingly need to gain 1 valence electron to attain the octet structure. So we see that they will give rise to anions of the respective charges. Note that anions ending with IDE are ions of their element. For instance, chlorine atom versus the chloride ion. Now there are some ions that's made out of more than one atom. These are known as polyatomic ions. Here are some polyatomic ions that you need to know for your syllabus. Now one thing you can note here is that I've underlined the word ATE as well as highlighted the oxygen in red. This is because when you see the name of an ion ending with ATE, you will know that it is a combination of that particular element, in this case nitrogen, and if it ends with ATE, is with oxygen. So therefore, nitrate is a combination of nitrogen and oxygen to form a polyatomic ion. Now it's difficult for you to deduce what's the charge of the ion as well as the number of oxygen atom, hence there's no easy way but to memorize this. For some transition metals, they may not have a oxidation state in their name. For instance, we have silver and zinc. You will need to memorize the charge of silver and zinc as it will not be shown in their name. So, here's a time for you to practice. What are the chemical formula of these ions? Write this into ClassKick and I will check your answer. Now we move on to writing chemical formula. Now, the formula of an ionic compound is constructed by ensuring that the total charge of the positive ions will balance the total charge of the negative ions. Like from its name, the symbol of the cation is usually written first. Subscripts are used to then represent the simplest ratio of cations to anions such that the total charges are balanced. Note that it's not needed to write subscript 1 in chemical formula. So just to give you the difference between superscripts and subscripts. We use superscripts for charges and subscripts for ratio. Again, if there's no number after the symbol, the ratio is 1. So in this case, magnesium is to chlorine is 1 is to 2. Let's look at the first example, sodium fluoride. First, let us check the type of bonding. We see that sodium lies on the left-hand side of the periodic table and fluorine on the right-hand side. Hence, from a metal and non-metal, we know that this is an ionic compound. Looking at sodium, we can tell that the electronic configuration is 2.8.1 based on the proton number. So, this tells me that it has one valence electron and hence it must lose one electron to attain stable noble gas configuration. By losing one negatively charged electron, it will have a positive charge. Hence, the formula of this ion is Na+. For fluoride, we look at fluorine. What is the electronic configuration of fluorine? Yes, it's 2.7. Notice that it must gain one electron to attain the stable noble gas configuration, and hence it will have a negative charge, F-. Now that you know the formula of its ions, how can I write the formula of its compound? Notice that they have one positive charge and one negative charge respectively. Hence, the charges will balance when the ions exist in the ratio of 1:1. So, the formula is just simply NaF. Let's look at a slightly more complicated example, aluminium oxide. Again, check that it's a ionic compound from a metal and a non-metal. Looking at aluminium, can you tell me the number of valence electron that you will have? Yes, that's right. You will have 3 valence electron and hence it must lose 3 electrons. This makes it have the charge of 3+, and hence the formula Al3+. Next, can you tell me what is the formula for oxide? What will be the charge for oxide? Now the electronic configuration, since it has 8 electrons in total, would be 2.6. This makes it have to gain 2 electrons to attain stable noble gas configuration, and hence having a 2 negative charge and the formula of O2-. With this formula, how can I then determine the formula of the compound? Notice that the charges do not balance at the moment, and hence I need to multiply the number of ions to make the charges balance. How do I do so? You can think of it in terms of what is the lowest common multiple of 3 and 2. So the lowest common multiple would be 6. Hence, I know that aluminium, which has a 3 positive charge, must multiply by 2, and oxygen, which has a 2 negative charge, must multiply by 3. The charges will balance when it's in the ratio of 2:3, and hence the formula is Al2O3. Now, note that for polyatomic ions, if there's more than one of the ion needed to balance the charges, we need to place the polyatomic ions in brackets before the subscript. Again, this is a metal and a non-metal. For the non-metal, for the anion in particular, notice that it's a polyatomic ion. Hence, write down their formula and we can see that the charges at the moment do not balance. One is 2 positive, the other is 1 negative. For it to balance, I need to multiply the number of nitrate ions by 2. Hence, the charges balance when it's 1:2, and I represent it by putting a bracket around the polyatomic ion and writing a subscript 2 outside. Now, what if there's no bracket? How are their meanings different? From the first formula, how can I count the number of nitrogen and oxygen? It's like math where you have to open the bracket by multiplying in. So we can see that there's 2 nitrogen here and 6 oxygen in total. What is clear from this formula is that there is a clear 1:2 ratio of the copper ion and the nitrate ion. For the second formula, note that there's the wrong number of atoms as the nitrate ions should be grouped together. This is a common error when you're beginning to write chemical formula, where the student only multiply the number of one atom in a polyatomic ion. If you look at the last example, even though it has the correct number of copper, nitrogen, and oxygen, it is unclear how these are grouped together. Okay, so it's not clear, at least not immediately, from looking at the formula that nitrate ions are involved. Hence, whenever there's a polyatomic ion, if there's more than one in its ratio, we need to bracket it and put the subscript outside. Let's look at another example, ammonium nitride. Ammonium is a polyatomic cation, nitride is an anion from nitrogen. So here are their formula. Notice that the charges currently do not balance. To balance it, I need to multiply ammonium by 3. Hence, the charges will only balance when it's 3:1, and this would then be the correct formula. Now it's your turn. Try to fill in the table with the corresponding name or formula of ionic compound